Guys, welcome to my channel. Today we are solving the June problem. So the problem goes like this. The title of the problem is surrounded regions. So let's see what it says. So given a 2D board containing X and O's, capture all the regions surrounded by the X. A region is captured by the flipping all the zeros into X in the surrounded region. So if we can see this example, so in this example we can see these three zeros, these three O's are actually getting captured by all the X's. Makes sense. After running the function, it should return something like this. Makes sense. Surrounded region shouldn't be on the border, which means that O's on the border are not flipped. Oh, border cases are not done. Any O's that is not on the border is not connect. It is not connected to an O on the border will be flipped to X. Two cells are connected if the adjacent cells are. So yeah, so all the borders will never be captured, and all the connected O's are also not captured. So that gives an interesting thing. So maybe what we can do is a simple solution to this is we will just go through the boundary O's and connected ones, mark them. Either we can maintain a new matrix altogether, but that will be unoptimized on the space time. So we will just get the O's connected, mark them in place with some other thing, and later on the point we will just do a post processing where we will just do with this special character, mark them O back and restore the O's to X. So yes, I think so that should work, and I think so we just need to go through the boundaries. We don't need to go through everything. So I think so the steps goes like run DFS on the boundary nodes, with val as O, mark them with some special character, let's say star, and post traversal on the grid to convert back star to O and O to X. Yeah, I think so this is optimized and should work. So let's try to see how we need to code this up. So yes, so let's try to select this. So first of all, what we need is, I think so we need a basic template, something like let's get the code from this thing. Yeah, I think so that's good. So what we need is we need a while DFS which takes the whole board, some I, some J, length of rows, length of columns. So this is our DFS. Internally what we have to do is, if we'll cover the boundary cases. So first of all, I think so let's compute the length of rows and columns. So length of row is itself is board dot size, and the columns will be if m is present, then board of 0 of size, otherwise it's 0. Okay, so now just loop through it for the rows. Okay, So you have to just go through the board boundaries. So we'll say if go for the first column, right? If this is O, right, then we have to go through the DFS with the code I comma 0 comma 1 comma n. Yep. We have to do the similar thing for the last column, so let's do it for that. I comma, what is the last column? N minus 1. We'll do it for N minus 1. Makes sense. Now we have to do for the other axis. So let's do for J for better velocity. So this is J. We'll check for the first row. J. This is M minus 1 and J. Okay, so this is how it need to be. Then we need to post traverse this thing. So post traverse is just simply, it's a simple thing. We'll copy this, then we'll copy this, we'll indent it properly. Cool. So here we say if the board of ij is equal to O, then convert the board of ij into an x. Let's take our wildcard character as star. So if it is star, then convert it back, because that boundary node can't be captured. Okay, so I think so this should work. We just need to return now, write our DFS function. So in our DFS function it should be simple enough. Let's do the safety net first. So I shouldn't cross the left boundary, I shouldn't cross the right boundary, J shouldn't cross the left boundary, J shouldn't cross the right boundary. If any of this happens, we just need to return it. Now if the board of ij is not equal to O, we also need to return this thing. The rest is we just need to traverse all the DFS for the other values. So we have to do, we can actually just get it from here. DFS of I minus 1j I plus 1j j minus 1 j plus 1, and simply return after this. One thing which we need to set is this. Now we need to convert this board into star whenever this happens. Okay, so this looks correct. Let's try to run this guy. We got a compilation error, line 11 extra comma. Yes. Okay, let's try to run this again. Okay, I think so we missed a ternary. So I think so line 25 is almost the same error. Let's fix that. Let's fix this. Let's fix this. Yep. Seems like it's done. It's the same thing. Let's try to submit this thing. Okay, cool. I think so that's all. It's a very simple problem. The time complexity of this thing is O of n, and the space complexity is also O of n.